We're going to do a separate session on now describing what is happening on your box and whisker plot. Here we are dealing with calculations. We'll talk about interpreting, how you find something which is left skewed or negatively skewed, and something which is right skewed or positively skewed. Don't worry, there's going to be a session on that, on interpreting. But for now, this is all about calculations. So for our calculations, let us now here talk about, again, the measures of central tendency. So we want to say measures of central tendency, then we'll talk about the measures of dispersion. Really what we must talk about is the measures of dispersion, but we need these measures of central tendency. We're going to need them. The mean, we're going to need it when we calculate the coefficient of variation. So we cannot forget how to get the mean. We need it. So for measures of central tendency, we are going to have on the left again, we'll say for ungrouped data. Okay, so I'm going to say for ungrouped data. Then on the right, we are going to have for grouped data. So it's going to be for ungrouped and for grouped data. So now we'll start with the first thing. It's going to be the mean. We're going to see the mean for ungrouped, then we're going to see the mean for grouped, okay? Like this. So now let's start. And for mean, we remember we are going to have two types of mean. We have the sample mean and the population mean. If it's sample mean, it is the mean when we are looking at part of the whole group. Then if it's population, it is when we're looking at every single thing of the whole population, the entire thing. So here we're going to start with number one is the sample mean. Okay? And when we use and when we do anything for sample, we don't use Greek letters, we use just normal letters. So the sample mean is going to be X bar. What is this going to be? The sum of terms divided by the number of terms. Okay? But what you should know is that, let me choose an easier crayon to use for this. What you must know is that we then put a more explicit form. So instead of just saying the sum of x, we say the sum of xi, which is from 1 up to n, then divided by n. This is just the sum divided by the number of terms, okay? And for grouped now, we'll be saying x bar, instead of just an xi, it is now going to be the sum of wf, okay? And w is the midpoint, f is going to be your frequency, the sum of wf divided by n. This is going to be for group data, okay? This is going to be the one which we use for group data. We can even say divided by the sum of frequency, okay? Which is going to be the total number of things. That is for group data. Then we say the population mean. Now let's put the population mean. The population mean is going to be mu bar. This is going to be what? The same formula, the sum of x terms, but divided by the total number of terms. We now use capital N, okay? And we'll be saying this is just from 1 up to n, okay? And we put the xi. Then this is going to be, now, the sigma again. This is going to be the summation of what? Over the summation of f. This is from 1 up to n, okay? Now, this is what we are going to do, and this is what we have. So this is it for mean, but we don't only need mean. We are going to need the median as well, and we are going to need the quartiles as well. So what is now median? We don't have two words. It's just one. We don't have sample, median, and whatever. No, it's just median, okay? There's no sample median and population median. No, it's just median. How do we get the median? Well, we look at first case I is when you have, we're dealing with ungrouped data here on the left. It is when you had odd number of terms. So if you have an odd number of terms, remember, for median, make sure that your data has been arranged in order of size. Once you have it arranged in order of size, then we can do this. So for median, we are going to say, if you have an odd number of terms, then we say median location, the place where you're going to find the median, is going to be equal to n plus 1 over 2. This is going to give you the location of the median, okay? You go to term number n plus 1 over 2. And remember, n is just the total number of terms, okay? What about when you have even things? Because look, be very good at finding the median, because the median is going to help you find Q1. It is going to help you find Q3, because Q1 is just the median of everything on the left of the median. Then Q3 is going to be the median of everything on the right of that median. Okay? So now, what about in the even? So even number of terms now, even number of terms, then how do we get the median if we have an even number of terms? If we have an even number of terms, then we're going to say median location. Okay? Median location is going to be what? Term number n is going to be term number n over 2 and term number n over 2 plus 1. Okay, the plus 1 is outside. This gives you the median location if you have even. Then you'll be now saying median will now be average of that. Median is now going to be average divided by 2. This is going to give us the median. Okay, it's going to be the sum, sorry. Mid is going to be the sum, which is going to be the average. So median is equal to the average of these two, which is going to be the sum, which is going to be sum over 2. Okay, there are two terms. So here you'll be now having a thing. And this is what happens, okay? Then now, what about median for group data? We'll come back. There's one more thing to do here. Is going to be now just the, this is going to be just the quartiles. So we still have the quartiles. All right, okay, no problem. What about the quartiles now? We have seen the median, how to get it. Make sure you know how to get it. The median location, you go to term number n over 2 and term number n over 2 plus 1. The 1 is outside. Then you take those two terms, you add them, divide by 2. That is if you have even number of things. Then now, how do you get quartile 1? Quartile 1 is equal to median again. So if you know how to get median, then you can find Q1. But it is now median of terms that are on the left of terms to the left of the median. Okay, terms that are to the left of the median. Every term that is on the left hand side of the median, then you are going to use it to Q1. Okay, all right. Then now Q3 is going to be now the median, which you use these methods that we talked about here to say, is it odd or is it even? Then you know the method. Now to get term number Q3 is going to be median. Remember this statement because it's going to be very important when you do it the question. I'm going to remind you to say, didn't we say that? So it's going to be median of terms that are to the right, terms to the right of the true median, to the right of the true median of the median. Okay, then we will have Q3. So these are the quartiles, and Q2 is just the median itself. So Q2 is going to be just the median itself. Okay, this gives us Q2. Oh my goodness, proud of you guys so much. Now what about if we have group data? Then how are we going to find the median and how are we going to find the quartiles? You say to me, what do you need them for? Oh my goodness, my friend, you definitely need them. You need the median. You're going to need it to plot the box and whisker plots. And you're going to need the quartiles to plot the box and whisker plot. There is no running away from this. So how do we now get the median? Remember these formulas. They're so similar. Okay, we say that median is going to be equal to, here again we say the quartiles, which is QJ, is going to be equal to. So for median, remember, it is always lower class boundary. You said lower class boundary of the median class. Just like here, it is going to be lower class boundary of the quartile class, QJ. And remember, J is just the quartile. Which quartile is it? Is it the first or the second or the third? So J is actually 1, 2, or 3. So it's lower class boundary of QJ. Okay? And then what do you do? You say plus. And here again for median, you say plus. So the formula starts with the lower class boundary. Then you say plus. Then you put a big fraction. Then at the end you multiply by class width. Then you put a big fraction again here. Then at the end you multiply by class width. Okay, that is the same for median. That is the same for quartile. Then below here it's going to be the frequency of the median class. Here in the denominator is going to be the frequency of the class where the quartile is in. Okay, the frequency of the class where you will find your quartile. Then now what about at the top here? At the top here it's going to be n over 2 minus the cumulative frequency of the class before median. What about here for quartile? It is J times n over 4 minus the cumulative frequency of the class before the quartile, so of QJ minus 1. Then we are going to have our values for group data. So remember, it is lower class boundary. Can you see lower class boundary? Yes. Plus, can you see plus? Yes. Can you see the fractions? Yes. Can you see that you've multiplied by class width at the end? Yes. Can you see the denominator is frequency? Yes. Can you see you are subtracting cumulative frequency? Yes. It's cumulative frequency of the class before median. Here it is cumulative frequency of the class before that quartile. So it's cumulative frequency of the class before. Then for median, it's n over 2. Then for quartile, it's jn over 4. And I cannot tell you how important this is. You see, if you want to get median for group data, and if you want to get quartiles for group data, make a cumulative frequency table. It's so important. Then now you are going to need to find the lower class boundary for the median class. How do you find it? You are going to look at one thing. And what is that one thing? You're going to look at n over 2. So the class, median class, so here we're going to say median class, it is going to be the first class where cumulative frequency should be greater than n over 2. And n is the total number of terms. Then this is going to give you your median class. Median class is the class where the cumulative frequency is greater than n over 2, okay? And n over 2 is this value here, which is going to be the fraction. Then what about the quartile class, the class with the quartile? Okay, the class with the quartile is just going to be the class where your cumulative frequency is greater than jn over 4, j times n over 4, which is this thing here, okay? The first class, the very first class where your cumulative frequency is greater than jn over 4 is going to be your quartile class, the class with the quartile, okay? Then if you want to find the median class, it's going to be the first class where your cumulative frequency, remember you always use cumulative frequency, is greater than n over 2. Then it gives you the thing. Look at how well you've done. I hope you remember the formulas. Lower class boundary at the end, plus in the middle, you put that big fraction there, and at the end of the fraction, you multiply by class width. Then inside your fraction, you divide by frequency. Then you have n over 2 for median, j n over 4 for this. Then we just subtract the cumulative frequency of the class before the quartile. Here's the cumulative frequency of the class before the median. And you are done. This is enough. And you must be able to get whatever you need for this box and whisker plot. So are we ready for the box and whisker plot? For calculations, yes. For calculations, you now have every tool. Now what is left is now just going to be interpreting. So we must be able to go to the tutorial right now and do every calculation that is demanded or that is needed for a box and whisker plot. Remember that for here you can say, instead of saying the numbers end at n, you can say up to k, where k is going to be the number of intervals. So this is just going to be what you need. And that is it. Going to the next one. Goodbye for now.